Imagine, just for a second, hitting download on a massive, full-length 4K movie and having it sitting perfectly on your device in less than a single second. Or picture a world where a world-class surgeon can control a medical robot on the exact opposite side of the planet with absolutely zero delay. Imagine walking into your Monday morning meeting and sitting down next to holograms of your colleagues that look, sound, and feel just as real as if they were physically standing right next to you in the room. I mean, it sounds a bit like science fiction, right? Well, it's not anymore. These incredibly futuristic concepts are rapidly becoming our actual reality. Welcome to this explainer where we are going to dive into the awe-inspiring world of 6G.
But wait a minute, I know exactly what you're thinking. Wasn't 5G supposed to be the ultimate technological revolution? I mean, telecommunication companies are quite literally still rolling out 5G towers in many parts of the world today. So why on earth are thousands of brilliant scientists and engineers already locked in labs spending billions of dollars building 6G? What is the massive rush? Well, as we're going to see today, the technology landscape is shifting so dramatically that 5G simply won't be able to keep up with the world we're about to inhabit. Okay, let's dive straight into this. Section 1. Why 5G isn't enough. Exploring the limits of current tech. You know, our technological evolution is moving at a blistering pace. Think about it. 1G simply gave us wireless voice calls. 2G brought us text messaging. 3G finally put the internet in our pockets. And 4G made high-definition video streaming and entirely new app economies possible. Today, 5G connects our smart devices and powers the whole Internet of Things. Every single generation fundamentally changed how we live. But this evolution, it isn't stopping. If 5G is the fast lane for our current smart devices, what's the massive problem that requires us to invent an entirely new highway? The short answer: data saturation. Despite 5G's really impressive speed, it's going to struggle immensely to handle the massive tsunami-like data loads heading our way. Think about modern artificial intelligence. It's not just running in some distant data center anymore. It's on our phones, in our cars, literally everywhere. And it requires constant, massive data exchanges. Add in millions of autonomous vehicles talking to each other, smart factories running high-end industrial automation, and billions of new smart sensors, and suddenly, 5G networks are facing severe congestion and major energy constraints. The pipe simply isn't wide enough for the AI revolution. So how do we fix it? Let's move to Section 2. Understanding next-gen 6G technology. Unpacking the solution. First things first, just to set expectations, 6G is not happening tomorrow. You don't need to run out and look for a new phone just yet. Current global research, which by the way involves unparalleled international collaboration between governments, massive tech giants, and universities, targets a commercial rollout around the year 2030. Right now, we are in the foundational research and development phase, building the very architecture for the next decade. So how does 6G actually achieve these mind-bending speeds? It all comes down to something called Terahertz communication. Right now, our networks use microwaves and millimeter waves, but 6G pushes into the terahertz band. These are ultra-high frequencies. Think of it kind of like upgrading from a simple garden hose to a massive citywide water main. Moving to these incredibly high frequencies allows for vastly better spectrum usage and capacity. It literally lets us push an unimaginably huge amount of data through the air in a fraction of a millisecond. And this massive data capacity unlocks one of my absolute favorite concepts in 6G: digital twins. Because 6G networks will be incredibly fast and AI native, meaning artificial intelligence is built directly into the core of the network from day one, we can create exact, real-time virtual replicas of physical things. Imagine a real-world car manufacturing plant. With 6G, an AI can maintain a perfect, real-time digital mirror of that exact factory up in the cloud. You could test a new robotic workflow in the digital twin, instantly see the results, and apply it to the physical factory without missing a single beat. And this brilliantly illustrates another wild feature: network sensing. Up until now, wireless networks really only had one job, right? Sending and receiving data. 6G fundamentally changes this. The radio waves used in 6G will actually bounce off physical objects, allowing the network itself to act like a giant, invisible radar. The network will literally be able to physically see and map its surrounding environment in high resolution. Your Wi-Fi router isn't just going to give you internet, it's going to know when you walk into the room, and, well, hopefully it won't judge your pajamas. Let's look at what this actually means for us in Section 3, speed and real-world applications, transforming reality.
The projected capacity jump here is just absolutely staggering. We are not talking about some incremental, barely noticeable upgrade. 6G is projected to be up to 100 times faster than 5G. But honestly, it's not even just about peak download speeds. It's about capacity and latency. Latency is that frustrating delay between sending a command and the action actually happening. With 6G, latency drops to near zero. We're talking microseconds. This means the connection is so deeply reliable and instantaneous that machines can actually react faster than the human nervous system.
Because of that extreme near-zero latency, critical industries are going to be completely transformed. Take healthcare, for example. A top-tier surgeon in New York could strap on a VR headset and operate on a patient in rural Africa using a robotic arm with absolutely zero lag. It would literally feel like their hands are right there in the room. In transportation, fully autonomous vehicles will communicate with each other, with pedestrian smart devices, and with the actual smart highways, all at the same time, processing millions of variables instantly to virtually eliminate traffic accidents. But what about our everyday experiences? Education and entertainment are about to become deeply, deeply immersive. We won't just be looking at flat screens anymore. Students will attend lifelike, interactive virtual reality classrooms, actually walking around historical environments or physically interacting with complex 3D molecules. And keeping in touch with your friends, it won't mean a pixelated, lagging video call. It'll mean full-scale, real-time holograms beamed straight into your living room. We are truly entering the era of mixed reality.
Zooming out to a macro level, 6G will allow entire cities to become truly intelligent. We'll have traffic grids that adapt instantly to ease congestion. Smart factories will use predictive maintenance to fix machines before they even think about breaking down. And crucially, 6G is expected to seamlessly integrate our normal terrestrial cell towers with low Earth orbit satellites. This means comprehensive environmental monitoring across massive spaces and true global internet coverage. Yes, even if you're in the middle of the ocean or the most remote desert on Earth. Of course, it's not all magic. Let's look at Section 4, Overcoming Challenges and Myths, Navigating 6G Roadblocks. Let's start by clearing up a really big myth, the idea that 6G is going to completely kill off Wi-Fi. The reality is quite the opposite. 6G is absolutely not a Wi-Fi replacement. Instead, as we move into the 2030s, 6G and next-generation Wi-Fi standards are going to deeply integrate. They'll act as partner technologies. Your devices will seamlessly and completely invisibly hop between a robust 6G network when you're outdoors and incredibly fast Wi-Fi networks indoors, without you ever noticing even a slight drop in connection. Another massive misconception is that all the 5G towers we're actively building today will suddenly just be useless garbage tomorrow. So the crucial point is this: 5G isn't going to vanish. It's actually going to serve as the essential base layer. 5G will handle standard mobile traffic, while 6G will be deployed specifically in areas of extreme demand, like high-density smart cities, heavy industrial hubs, and for those super high-bandwidth applications like the holographic halls we talked about. They are going to work together. But the actual roadblocks to getting there? Oh, they are very real. Scientists and policymakers are grappling with massive infrastructure costs right now. Building out terahertz towers definitely isn't cheap. Furthermore, the energy demands of pushing this much data are pretty staggering, so we're going to require major breakthroughs in green tech to actually power it all. And perhaps most critically, with literally everything connected, security threats multiply exponentially. 6G is going to require advanced, quantum-safe security protocols to protect our data, alongside some incredibly complex global regulatory agreements to make sure different countries' networks can actually talk to each other. So, what does this actually look like for you? Let's jump to Section 5, Your Life in 2035. A seamless future.
Picture this. You wake up, your smart home powered by an interconnected edge AI system running on the 6G network has already perfectly anticipated your needs. The temperature in your room shifted perfectly 20 minutes ago. Your AI assistant, analyzing secure data from your smart sleep tracker, knows you need an extra boost, perhaps noting how late you were scrolling last night, so it automatically brews a slightly stronger coffee. It's already reviewed your schedule, optimized your transit times based on real-time city data, and subtly briefs you on the day ahead as you walk into the kitchen. You step outside into your autonomous vehicle. You aren't driving, of course. You're relaxing, maybe reading, or finishing up a presentation for work. The car is communicating instantly with thousands of other vehicles on the road, with the traffic lights, and even with the pavement sensors beneath it. Because of 6G's instantaneous network sensing and zero-latency data sharing, there are no traffic jams. None. Your commute is completely stress-free, all powered by this invisible, intelligent connectivity.
And then, when it's time for your biggest meeting of the day, you don't board a plane. You don't even open a basic video window on a laptop. You step into a collaborative workspace, and you appear as a perfectly rendered, real-time hologram in an office in Tokyo, while a colleague from London projects right into your room. You make eye contact, you read body language, you point to 3D virtual models hovering in the air between you. The barrier of geographic distance just fundamentally disappears.
And honestly, that is the ultimate takeaway here. 6G is way more than just giving you faster internet on your phone. It is about building an intelligent, global communication platform. It's quite literally the central nervous system for the future. A system where human beings, complex AI, robotics, orbital satellites, and entire physical cities are just interwoven into one cohesive, real-time network. We are literally standing on the precipice of a completely interconnected world. So, as we wrap up this explainer, I really want to leave you with this final thought. If 6G succeeds in making almost everything in our physical world connected, aware, and highly intelligent, how will that change your life, your career, or your passions? Think about it. I'd absolutely love to hear your most visionary thoughts, so please drop them in the comments down below. If you found this breakdown valuable, make sure to hit subscribe so you never miss our next explainer. Keep learning, keep looking to the future, and I'll see you next time.